Hi, this is a video on adding and subtracting rational expressions with like denominators. Remember that rational expressions are fractions. Okay, they're fractions where you have a polynomial in the numerator and a polynomial in the denominator. Okay, so that means they're fractions. And then like denominators just means that the denominators are the same. So the word like here just means the same. So they have the same denominators. Okay, and this is pretty similar to my other video where I showed you how to add and subtract fractions with the same denominator. It's just here rational expressions can be harder because you have to end up factoring them so that stuff will combine or cancel out. Okay, so they are a little bit harder than the ones we did way earlier in the semester because here we end up having to do things like factor and then cross out common factors and all that stuff to simplify. Okay, so let's jump into an example of these. Okay, so example. The instructions are add or subtract as indicated. Add or subtract as indicated. And sometimes they will tell you to simplify. Other times, if they don't tell you to simplify, you should automatically know that you're supposed to simplify because it's math. Okay, so we need to simplify if possible. Whether they tell us or not, you always have to simplify. Okay, so for our first example, we're going to do a relatively easy problem. Okay, so for example number 1, we have 10x over 5x minus 7 minus 14 over 5x minus 7. Okay, so 10x over 5x minus 7 minus 14 over 5x minus 7. Now these are like fractions. These are rational expressions which are fractions with like denominators. They have the same denominators. So how do you combine them? Well, it's a little bit different from multiplying or dividing. So what we're going to have to do here is, in order to combine these, we need to keep the denominator and then add or subtract the numerator. Okay? So to add or subtract like fractions, in other words, rational expressions with like denominators, basically what we have to do is keep the denominator. Okay, so the denominator stays the same, but then we add or subtract the numerator. Okay, so keep the denominator and add or subtract the numerator. Okay. All right. So bottom stays the same. We combine the top. So like here, what that means is because they have the same denominator, the denominator is 5x minus 7 for both of them. We're going to get 10x minus 14 all over 5x minus 7. Okay, so this whole thing, let me zoom out a little bit. This whole thing is going to become, in the numerator we have 10x minus 14, and then we keep the denominator, so the denominator is going to be 5x minus 7. Okay, and you can do that as long as the denominators are exactly the same. Here the denominators are exactly the same, so they're like denominators. Okay, so you keep the denominator and add or subtract the numerators. So that, let me zoom back in so we can read it better. So we got 10x minus 14 over 5x minus 7 Well, I erased stuff, so let me just erase it. Okay, so 10x minus 14 over 5x minus 7. I've got red pen here. Whew, what a disaster. Okay. All right, and then what can we do from here? Well, like I said, the thing about rational expressions is they have a polynomial on the top and the bottom. So after you've added or subtracted, like we have here, you still need to simplify. Okay, so that's going to be our next step here, which is going to be to simplify. So to simplify this, like I said, you want to factor the top and the bottom. Okay, so we're going to simplify by factoring. All right, and then after you factor, you cross out any common factors, just the same way we did in the last lecture on multiplying and dividing rational expressions. So here in the numerator, we can actually factor out the GCF. So the biggest number that goes into both 10 and 14 is going to be 2. So on the top, we can factor out a 2. So on the top, we have 2 times 5x minus 7. Okay, 2 times 5x minus 7. And then on the bottom, we can't factor it, so we just leave it as 5x minus 7. I put parentheses around the denominator just so that you would notice something. If you notice here, we actually have a 5x minus 7 on the top and the bottom, so those two are going to cancel out. Okay, so these two cancel out, and what are we left with? We're left with 2 on the top and then 1 on the bottom. Because if you cross everything out on the bottom, there's still a 1 left over. All right, so here we just have 2 over 1. But remember, you don't need to write 1 in the denominator. So our actual answer is going to be 2. Okay, so that's going to be our final answer. Okay. And if you want to check these, you don't have to, but if you want to check them, I suggest that you just read through your steps and make sure that your steps make sense. That's the easiest way to check these. And of course, if you're doing it on My Math Lab, it'll tell you right away if you have the wrong answer. And then if you need extra help, you can look at View an Example or Help Me Solve This. Okay, so that first one was relatively easy. It's supposed to be easy anyway. Okay, so let's go on to some harder ones. So let's take a look at example number 2. So for example number 2, we have 2x squared plus 9x all over x minus 9, okay, minus 16x plus 99 all over x minus 9. Okay, so 2x squared plus 9x all over x minus 9 minus 16x plus 99 all over x minus 9. So we are subtracting here, and we do have the same denominator. Okay, so since these are like denominators, remember the way we do this is we keep the denominator and then we add or subtract the numerators. However, there's something we need to be careful about here. In the numerators, we actually have more than one term. So if you're subtracting, it's really important to put parentheses around the numerator if it has more than one term. So I'm going to put parentheses around this numerator up here on the top right. Okay, and that's because I'm subtracting, so I'm actually going to end up having to distribute the negative. Okay, so what's this going to look like? Well, we keep the denominators and then we subtract the numerator. So the denominator is going to stay as x minus 9, but now in the numerator, we're going to have 2x squared plus 9x minus parentheses 16x plus 99. Okay, 2x squared plus 9x minus parentheses 16x plus 99. So all we did was we kept the denominator and then we subtracted on the top. And I put parentheses around the 16x plus 99 because it had more than one term. And as you can see now, the reason those parentheses were necessary is we actually are going to need to distribute that minus on the top right. So we're going to distribute this minus to each of those last two terms. So when we do that, that's going to switch the signs of those terms. So they were both positive. Now they're both going to be negative. Okay, so we're going to get 2x squared plus 9x minus 16x minus 99. Okay, and then this is all over our common denominator, which is x minus 9. Now you might think you're almost done with this problem because we've already done a fair amount of work, but we're not actually done because we still have to simplify this even more. So in the numerator, we can combine like terms. Okay, so if we combine the 9x and the negative 16x, those are like terms because they have the same variables raised to the same powers. So we know that 16 minus 9 is 7, but because the larger number is negative, it's actually going to be negative 7x. Okay, so we're actually going to have 2x squared minus 7x minus 99 all over x minus 9. 2x squared minus 7x minus 99 all over x minus 9. And then, once again, you would think you'd be done, but you actually need to factor here. Remember, just like in the earlier problems on multiplication and division, when you're simplifying at the end, you have to factor and cross out any common factors. Okay, so we're still not done. So how do we factor the numerator? Well, it has three terms. So we're going to factor using the x method. So over here for the numerator, I'll write an x. Okay, and on the top, we do the first term times the last term. So that's going to be 2 times negative 99, which is going to be negative 198, right? And then for the bottom, we have negative 7. And here, these numbers are pretty difficult to work with. So you might just try trial and error here. So for example, we could do, in order to get 2x squared, we know that we're going to need a 2x and an x. Now why do we know that? Well, we need a 2x times x gives you 2x squared when you're using FOIL. So we know that already. And then it's just a question of numbers that multiply to negative 99. Numbers that multiply to negative 99, I would think of 9 and 11. And those are 2 apart. Okay, and then if we do, if we do negative 11 and positive 9, that's not going to work because outer plus inner is going to be negative 22 plus 9, so that's not going to work. So what we're going to have to do is we're going to have an 11 here and then a negative 9 over here. And that should work. So what I'm doing is called trial and error, where I'm just trying different things and then seeing if they work. So this method of factoring is called factoring by trial and error. And the reason I resorted to this, where I'm basically just trying stuff, is because I saw the numbers up here were kind of big. So I decided I'd rather just try things until I find something that works. Now, I knew I had to have a 2x and an x in order to get a 2x squared, because remember, these are multiplied together. And then the outer plus the inner here is going to be 2x times negative 9 is negative 18x plus 11x. That's going to give us negative 7x. And then 11 times negative 9 gives us negative 99. Okay, and if you don't like doing it this way, you can do it the way we did in earlier lessons where we used the X method and then factoring by grouping. Okay, but I would recommend when the numbers are awkward like this to just do trial and error is usually the easiest way. But if you wanted to do it up here and you wanted to do it by grouping, you would need two numbers that multiply to negative 198. Okay, and I guess they would be negative 18 and negative 18 and positive 11. Is that right? Well, you can always check it on your calculator. But as you can see, those numbers are big because they don't show up in your times table, so it's kind of hard to work with those numbers. But negative 18 times 11 is 198. Yeah. So the problem with doing it with the X method is how do you come up with those numbers? How do you come up with negative 18 and 11? Well, it's kind of tricky. Whereas trial and error was actually really easy for me here. It was not so bad. Okay, either way, so now we have it factored. So what we can do next is now we get to do the fun part, which is just cross stuff out. So now we notice that we have an x minus 9 on the top and the bottom. Okay, so we can cross out those x minus 9s. So we're really just left with 2x plus 11 all over 1. Remember, if you cross everything out, there's still a 1 left in the denominator. But remember, any number divided by 1 is just a number, so you don't actually have to write that 1 in your answer. Okay, so your answer is just going to be 2x plus 11. Okay, 2x plus 11, and then that's it. All right, so that one is hopefully not too bad. And then you have another problem in your homework. I'm going to skip the next one because it's pretty similar to what we just did. Just keep in mind that when I say factor, you need to factor the numerator and the denominator. But once you do that, you should know how to do the other one. So I'm going to skip that one because it's pretty similar. So let me go on to a later problem. This one's a little bit harder. Okay, so that was example number 2 that we just did. So let's take a look at example number 3. Now the difficulty is going to go up here a bit, mostly just because it's a long thing to write out. So for example number 3, we have 4x plus 5 all over x squared minus 9x plus 20. Okay, so 4x plus 5 all over x squared minus 9x plus 20 minus 3x plus 10 all over x squared minus 9x plus 20. Okay, so 4x plus 5 all over x squared minus 9x plus 20 minus 3x plus 10 all over x squared minus 9x plus 20. So this one's harder because the denominators are larger. But you will notice that these two denominators actually are identical. So these are still like denominators, okay? These are like denominators, which means they're the same. Okay, and if they're the same denominator, you just keep the denominator and you add or subtract on the top. But on the top here, I see the 3x plus 10, since we're subtracting that and it has more than one term, I'm going to put parentheses around the 3x plus 10. Okay, and then we just keep the denominator. So we're going to keep the x squared minus 9x plus 20. But then we're going to subtract in the numerator. So in the numerator, we're going to have 4x plus 5 minus parentheses 3x plus 10. Okay? 4x plus 5 minus the quantity 3x plus 10 all over x squared minus 9x plus 20. Okay, and then what do we do from here? Well, just like in the earlier problems, our next step is to distribute the minus. So we're going to distribute this minus to the 3x plus 10. Okay, so let's do that. Okay, so we're going to have 4x plus 5 minus 3x minus 10. Because remember, when you're distributing a minus, that switches the signs. So plus plus becomes minus minus. And then our denominator is still x squared minus 9x plus 20. Okay, and then now in the numerators we can combine everything that's a like term up here. So we have 4x minus 3x, and then 5 minus 10. Okay? So for the 4x minus 3x, that's 1x. Okay, but remember 1x is just the same as 1, because 1 times any number is the number. So that's just going to be x. And then we have 5 minus 10 on the top, which is negative 5. So on the top now we have x minus 5. And then for our denominator, the x squared minus 9x plus 20. This time, because our denominator is factorable, we're going to actually factor the denominator. And sometimes you'll have to factor both the numerator and the denominator, and then cross stuff out. And we did some of that on when we were doing multiplying and dividing rational expressions. So you've already seen that before, but you actually have to do that on some of these as well. But here the numerator is already factored, but the denominator needs to be factored. Okay, but these numbers are pretty easy, so we can just use the x method here. Okay, so the x method, on the top of our x is going to be 20, and on the bottom we have negative 9. Okay, so we want two numbers that multiply to 20, but add to negative 9. And when I think of numbers that multiply to 20, the first ones I think of are 4 and 5. Okay, but then to add to a negative number, they both have to be negative. Because negative 4 times negative 5 is positive 20, the minuses cancel. But then negative 4 plus negative 5 is negative 9. Okay, so we have x minus 5 all over x minus 4 times x minus 5. Okay? And in the numerator, we're going to put parentheses around it. And the reason I'm doing that is just so that, because it has more than one term, I want to point out to you that now we have a common factor of x minus 5 on the top and the bottom. Okay, and because we have that, we can cross those out. Cross out the x minus 5s. So now you would think for your answer, well, if you cross everything out, you have a 1 left on the top, right? So you have a 1 left on the top, and then we have an x minus 4 on the bottom. But then you might be thinking, oh, well, didn't Mr. Shoemaker say that we don't have to write a 1 because any number divided by 1 is the number? And the answer would be yes if the 1 was on the bottom, but here the 1's on the top. So the 1 is in the numerator here, and in this case, if the 1's in the numerator, you can't erase it. So important note, this does not equal x minus 4. Okay? So those are not equal. Okay? So this is the wrong answer. You can't write it as x minus 4. Because if you have 1 over something, that means something different than x minus 4. Because x minus 4 by itself means x minus 4 over 1. Okay, so because you can't do any of that, that means our answer is actually going to be 1 over x minus 4. Okay? And that's the whole thing. Okay, so that's how you want to write your answer for that problem. Okay. And now adding rational expressions is pretty similar. We haven't really gotten to do an example of that yet. So I wanted to do 1. Okay. So this is going to be our last example on this video. So for this one, we're going to be on example number 4, because that last one we just did was number 3. Okay, so for example number 4, we're going to do 6x plus 5 all over x minus 4 plus negative 4x minus 13 all over x minus 4. Okay, so 6x plus 5 all over x minus 4 plus negative 4x minus 13 all over x minus 4. Okay, so this time we're adding instead of subtracting, but this one is actually really easy. Adding is actually easier than subtracting. So here they have the exact same denominator, which is x minus 4. So they have like denominators, which means we keep the denominator and we add on the top. Okay, so on the top, you could put parentheses around the 4x, the negative 4x minus 13. But it's not really necessary because you're just adding, you're not subtracting or dividing or multiplying. Okay, so on the top we're going to have 6x plus 5 plus negative 4x minus 13. Okay, and then in the denominator we have x minus 4. Okay. All right, and then remember when you're adding something, it doesn't change the sign of the terms. So like a plus and a minus don't do anything. So this plus isn't really doing anything. So instead of writing plus negative 4x up here, I can just write it as negative 4x minus 13. Okay, and then we can combine like terms. So the like terms here are 6x and negative 4x on the top, and then 5 and negative 13 on the top. Okay, so combining those, we have 6x minus 4x is 2x, and then 5 minus 13 is negative 8. So we have 2x minus 8 all over x minus 4. Okay. And then, of course, you're not done because you still need to factor. So what can we factor here? Well, the only thing that's factorable is the numerator, and all we can do is factor out the GCF. So in the numerator, we're going to factor out the GCF. And what's the biggest number that goes into both 2 and 8? Well, 2. So we're going to factor out a 2 on the top. Okay, so we have 2 times the quantity x minus 4 on the top, and then on the bottom we just have x minus 4. Okay, and then we can see that the x minus 4s are actually going to cancel out. And so we're left with 2 over 1, right? Because if you cross everything out, there's still a 1 left over. But remember, if the 1 is in your denominator, you don't need to write in your answer. If the 1's in your numerator, you have to write it in your answer. So for example, if it were 1 over 2, that would mean 1/2. But 2 over 1, you don't need to write the 1 down there. Okay, so our answer is just going to be 2. Okay? And that completes all my examples for this video. So thanks for watching.